Assalamu alaikum everyone, and I hope you all are fine. Today we are going to study chapter 7, Energy and Forces. It's lesson 7.3, Electricity and the Circuits. So students, this is on in your book, page number 102. So let's start lesson 7.3. So everyone open page number 103. When we press a button on the switchboard, a light bulb or a fan turns on. This happens because of flow of an electric current in a complete circuit. Our lives are so dependent on electricity to work. Electricity always travels in a circuit, as we studied earlier. Okay, students, whenever if you see a switchboard, so if you turns it off, so what happens? The bulb or a fan turns on. And if we turns it off, sorry, if we turns it on, so the bulb or a fan turns it on. Okay, and why this happens? Because of the flow of an electric current. It is present in a complete circuit. As there is a circuit, and because of the flow of an electric current, this happens that we can switch on the electrical appliances as well, and we can switch off them as well. And our lives are almost dependent on electrical appliances, as we work from them. And electricity always travel in a circuit, as I told you all. Okay, you can see in the diagram that we call this a bulb, and this is a cell or we can attach battery as well, but a cell is attached in this diagram. So students, right now move on to page number 104. Electricity flows through wires. Usually the electricity we use in our homes comes from power station. It is called mains electricity. In power stations, there are huge generators. They generate electricity. Batteries also provide electricity to electrical appliances. The things which work on batteries are called battery powered devices. Okay, so here it means that uh, from where electricity flows through wires. This is compulsory, this we all know. Okay, and the electricity which we use in our homes, it comes from power stations. Power stations, it can also be called as mains electricity. And in power stations, there are huge generators placed there, and through which they generate electricity. In power stations, there are huge generators placed there, and they produce electricity because of that, and which we use in our homes, offices, and other places. Obviously, when we talk about electrical appliances, so batteries also provide electricity to them. And the things which work on batteries, we call them that they are battery powered devices. For example, you can see that we use some appliances, some gadgets in our home that uses batteries. So we call that appliance or that gadget a battery powered device. And you can see a power station picture as well in the book, page number 104, that how it generates and how we get it in our home. through wires, as wires are attached from the power station, and then we get it in our homes. So moving to page number 105. Conductors and insulators. Materials which easily allow electricity to pass through them are called electrical conductors. All metals like copper, iron, silver, gold, etc. are conductors of electricity. Most of the wires we use are made of copper from inside. Some materials do not allow electricity to pass through them. They are called electrical insulators. Glass, wood, paper, plastic, etc. are some insulators. Okay, students, first of all, you should know that what is the difference between conductors and insulators. If we talk about electrical conductors, so those materials which easily allow electricity to pass through them. It means we can those materials which can easily allow electricity to be passed through them. For example, copper, iron, silver, gold, etc. And they allow electricity to pass through them. So they are called electrical conductors because they allow electricity to pass through them. And obviously most of the wires which we use are made of copper from inside. Okay, for example, if you have a charger, so almost they are made of copper wire from inside. This was electrical conductors which we studied. Now moving to electrical insulators. So what are that? It's the opposite of electrical conductors. There are some materials which do not allow electricity to pass through them. Okay, so they are called electrical insulators. For example, glass, wood, paper, plastic. They all are electrical insulators. Why? Because they do not allow electricity to pass through them. Up till here, everyone clear with conductors and insulators? So, moving to types of circuits. The flow of electricity is called an electric current. The path along which electric current travels is called a circuit. Circuit is just like traffic flows on a road. A circuit in which current can flow without any break is called a closed circuit, while in circuit in which there is a break for current flow is called an open circuit. Okay, students, first of all, we got to know that what are the difference between conductors and insulators. Now we will read that what are the types of circuits, okay, and what is the circuit. First of all, you should know. So basically a circuit is the flow of electricity. Okay, for example, the flow of electricity from which electricity can flow is called an electric current. Okay, and the path, it means the way along which electric current travels is called a circuit. Circuit is just like traffic flows on a road. For example, traffic is flowing on a road. It is just like that. Circuit is just like that. Okay. And how it is same like that? Beta, it is same like that. For example, electric current is traveling in a circuit. Okay. So it is called a circuit. And first of all, you should know that what is a closed circuit and what is an open circuit. Beta, a circuit in which current can flow without any break is called a closed circuit. For example, beta, if there is no error or there is no breakage in a circuit and through which current can flow easily. It is mean it is a closed circuit. But if there is any error or if there is any breakage in the circuit, we can call it a open circuit. As you can see in the diagrams as well, that this circuit is called a closed circuit because electricity can flow easily. And you can see that the bulb is lightning. Okay. And its switch is not break or the wire is not break. So it is called a closed circuit. But if we compare it to the open circuit, so you can see that it has a breakage in the switch, and because of the breakage in the switch, the bulb cannot light up, and we call it a open circuit.